I'm going to do a couple of problems that are directly from your notes. And the first one I'm going to do is problem number 44, right here, 44. You should have it right in front of you, so that's why I'm not zooming in. It reads, an environmentalist finds a certain type of tree grows in such a way such that its height after 2 years is changing at a rate, okay, so rate of change of h prime of t equals this function. If the tree was 2 feet tall when it was planted, how tall will it be in 27 years? Okay, so the first thing that I want to address is that it says the tree was 2 feet tall when it was planted. Okay, so if we're thinking about what time that is, then t equals 0 makes sense, right? So at time 0, at the very first moment that it was planted, it was 2 feet tall. Okay, so let's keep that in mind. So the height at time 0 is equal to 2. Okay, so then they ask, how tall will it be in 27 years? All right, so a couple of things I want to point out. It does say rate of change, so it should be labeled as either change in y or change in x or derivative. Again, they're saying what happens at a specific time, so this should definitely be the derivative. All right, so let's get to this. All right, so what do we have? We know that for problem number 44, the rate of change of the height, h prime of t equals 0.2 t to the 2/3 plus the square root of t, which I'm going to just write as t to the 1/2 for the sake of space and time. Okay, we also know that the height at time 0 is equal to 2. Notice they're not saying the height is changing at 2 feet per year, but they're saying instead the height at 0 is 2, right? So there's a difference between your rate of change, which is telling you how fast, and your amount of change, which is telling you how much. All right? So if you read the question closely, you always want to stop, and I'll show you what I mean. You always want to stop somewhere before you get to the end of the problem. So notice I went all the way to here, and I stopped right before the how, okay, to see if I can come up with a height formula. All right, so we need the height formula because the question says how tall will it be. So they're not saying how fast it's changing, they're saying how tall will it be. So they're asking us to get to h of t. Only way to get there is to take the antiderivative. So the antiderivative of h prime of t dt. Notice the antiderivative and the derivative cancel each other out. They just give you h of t. So this equals the antiderivative of 0.2 t to the 2/3 plus t to the 1/2, the whole thing dt. You'll notice that I'm careful to match up my dt's with t's. If these had x's in it, if this had x in it, then I put dx. Okay, so let's do this. By 0.2 t to the 2/3 plus 1 is 5/3, and then we're going to divide by 5/3 plus 1/2 plus 1 is 3/2, and then we'll divide by 3/2 plus c. Okay, so at this particular point, c could be anything. We don't know what c is. So let's rewrite this as h of t equals 0.2 over 1 times 3 over 5, right? Divided by a fraction is the same as multiplying by the reciprocal, plus, there's a 1 over 1 here, 1 over 1 times, give me a second, I've made an error, and it's right here. This should be 3/2. Times 2 over 3, and this will, I don't know why I'm leaving out the variables. This is t to the 5/3, and this would be t to the 3/2, like that. Okay, let me zoom in so that you can see what that looks like. Okay, so let's simplify that further. Then h of t equals 0.6 over 5. This is the cube root of t to the 5th plus 2 over 3 square root of t cubed plus c. Okay, over here I should have plus c also. Okay, so now I need to keep in mind that I have an initial condition. So up here they're telling me that my height at time 0 is equal to 2, right? So time 0 being when you planted the tree. So h of 0 equals 0.6 over 5 cube root of t to the 5th, 0 to the 5th, plus 2 over 3 square root of 0 cubed plus c. This should equal 2. Right, so I'm going to focus on this part right here. Right, I don't need that earlier label, it's unnecessary. So what do I get? 0 plus c equals 2. So then clearly c is equal to 2. Alright, so I'm not done, obviously, because I have to take the c value and plug it back into my equation. So I have to take the c value here and plug it in for that. Alright, so my general h of t formula is 0.6 over 5 cube root of t to the 5th plus 2 over 3 square root of t cubed plus 2, right? Now that we know that c is equal to 2. C isn't just anything, c is equal to 2. Alright, so let me look back at my problem because I don't think I've answered it. Okay, so I'm going back to problem number 44. Let me zoom in on that so that you can see what the question was. Here it is. How tall will it be in 27 years? Now that we know the general height formula, we can simply just plug 27 in for t. Okay, so this is h of 27. Hold on one second. Is equal to 0.6 over 5 cube root of 27 to the 5th plus 2 over 3 square root of 27 cubed plus 2. Okay, of course you have to be paying attention to the units, and it says that your tree is growing in feet, so you're going to get a number and the units you're going to slap on that is feet. Alright, so there's problem number 44.